One very common job that we need to do in the laboratory is to measure the volume of a liquid. And the easiest way to do that is to dump the liquid into a graduated cylinder. A graduated cylinder is a piece of glassware that looks like a long tube. It's got a foot on it so that it stands upright. And it's got stamped on the side a series of markings that you can read volumes from. And the units that these graduated cylinders read off in is the usual units, milliliters, thousandths of a liter, with a liter being about a quart. Now, if you look at these graduated cylinders carefully, you notice that the scales are all different. If they're different sizes, very often the distance that the marks are apart is going to be different. The closer the marks are together, the easier it is going to be for us to read the graduated cylinder's volume precisely. Now let's look at some of these and see how far apart the marks are. This one is a 10 milliliter flask, and it looks like the marks, this is like a milliliter right here. And it looks like there are 5 marks between there. So every one of the marks on this one is 2/10 of a milliliter apart. Now if you look right here, stamped on the side, it says 10:0.2. It's telling you how far apart the marks are on this. And if you look at this one now, it's a 25 milliliter graduated cylinder. And how many marks do we have between 20 and 25? If you count them, there are 10. So 1/10 of 5 is 0.5. So these marks are 0.5 milliliters apart. And you can tell that because it's stamped on the side of the graduated cylinder up here too. It says it's a 25 milliliter graduated cylinder with marks that are 0.5 milliliters apart. You can look at this one. It's a 50 milliliter graduated cylinder, and the marks are 1 milliliter apart. Let's double check that. There's the 40 mark, there's the 50 mark, and there are 10 marks between them. So each mark is a milliliter apart. How about this one? We can't see the top of it. We have to decide for ourselves how far apart the marks are. Well, let's see. Here's 50 and here's 60. And how many marks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 divisions there between 50 and 60, which is 10 milliliters apart. So if you take 10 milliliters and divide it by 10, these are 1 milliliters apart, these marks. Now that's the first step in learning to read a graduated cylinder. The first thing you have to decide is how far apart are the marks. So let's put some liquid into one of these graduated cylinders and try to read the volume from it. Now the first thing that we notice is that we don't get a nice flat liquid surface to read from. We get a curved surface like this. This kind of curved surface is called a meniscus. And it happens because the liquid inside, let's say water, wets the glass. And when it wets the glass, it tries to spread out as much as it can along the glass. And that'll cause it to creep up a little bit around the edges of the graduated cylinder. In the very center of the graduated cylinder, then, it'll be lower than it is around the edges. So where do we read? Do we read up here or do we read down here? The second thing. You read across the bottom of the meniscus all the time. The marks on the side of the glassware are stamped there, assuming that you're going to do that. And it is also a lot easier to read across that point. Now sometimes in real life, you're going to have to do what I did here in the picture, and that is to put something colored or something dark or light behind the graduated cylinder so that you get maximum contrast. The other thing you're going to have to do is, if you want to read across the bottom of the meniscus, is make sure that your line of sight is perpendicular to the barrel of the graduated cylinder. So if you're looking, you're a little bit high and you're looking down, or you're a little low and you're looking up, you're not going to see where the bottom of the meniscus is relative to the marks very well. Now, the next thing we need to do after we notice the meniscus there is we have to figure out how far apart the smallest scale division marks are. So here are the smallest marks. How far apart are they? We can't just read it across the top of the graduated cylinder in this case. So let's see, here's the 3 milliliter mark, and here's the 4 milliliter mark, it looks like. And I've got 10 marks between there if I count them. So this is 1 milliliter distance from here to here with 10 marks. So each one of these must be 1/10 of a milliliter apart. Now that we know that the marks are 1/10 of a milliliter apart and we know where the meniscus is, we can look at which marks bracket the meniscus. This mark is just a little bit lower, it looks like to me, than the bottom of the meniscus, and this mark is just a little bit higher. So those are the marks that bracket it. So let's read off what those marks are. Let's see, here's 3. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6 is this mark. Now, would I report the volume as 3.6? No, because it's a little bit more than 3.6. You can see it's a little bit higher than 3.6. Now, the next higher mark is 3.7. So would I say, well, the volume is somewhere between 3.6 and 3.7? You'd be right, but that's not how you do it. What you're going to need to do is estimate to the nearest 1/10 how far the meniscus is up from the bottom scale division. It's up just a tiny bit. I might say it's maybe 1/10 of the way up. And in that case, what I'm going to do is add 1/10 of 1/10, which is 100th, right, to my 3.6. So if I have 3.6 here and it's 1/10 of the way, 1/10 of 1/10 up, that's going to be 0.01. So it'll be 3.61 is the reading that I would have off of here. Now, what if you read it a slightly different way than me and you said, well, I think the meniscus is right on that mark. I don't see any daylight between there. Well, I do, but maybe you don't. That's fine. How would you read it? You can't just say 3.6. You have to read to the nearest 1/10 of a scale division. They're 1/10 apart, and you have to read to 1/10 of that. So you have to read to the nearest 100th. And if I think this is right on the mark, I'm going to not write down in my notebook 3.6 milliliters. I'm going to write 3.60 milliliters. I'm going to put the last mark into the hundredths place to show how finely I've read this. So you can tell from looking at someone's measurement how far apart the scale divisions were. If someone writes 3.6, the scale divisions were only 1 milliliter apart, because they must have been judging that 0.6. If they write 3.61, the scale divisions must have been 1/10 apart because they're judging to the nearest 100th. So you estimate out one more place than the marks can tell you directly. So let's recap that whole procedure. I want to read the liquid level in this graduated cylinder. First thing I do is I notice how far apart the marks are. Going from 3 milliliters to 4 milliliters, that's 1 milliliter. And there are 10 marks in there, so the marks must be 1/10 of a milliliter apart. Now, I'm going to look at which marks bracket the bottom of the meniscus. Looks like 3.1, 2, 3, 4, 5, 6. 3.6 is lower than the meniscus, and 3.7 is higher than the meniscus. Now, what I'm going to try to do is read to 1/10 of the smallest scale division. How far above the bottom mark is that bottom of the meniscus? Well, it looks to me like it's 1/10 of the way up, and the marks are 1/10 of a milliliter apart. So it's 1/10 of 1/10, which is 100th. Now I'm going to add that to the volume for the lower mark. 3.6 milliliters plus 1/10 of 1/10 is 3.61 milliliters, will be my reading. Now remember that procedure. I'm going to have you read graduated cylinders definitely on the test.